let's record this so we can at least put it on. So that the rest who aren't here, and for posterity, I thought we were recording all this. Okay, which one of the following compounds? No, we don't. This we will get to. Fertilizers, okay, there looks like a question. Which one of the following pairs of compounds are functional isomers? Now, you know what? Do you know what a functional isomer is? They've got the same molecular formula, but a different structural formula. They've got the same atoms, but a different functional group. Methanol, methanal. Could that be an isomer? No, that's got a double bond O. That's got a single bond O. That's not a functional isomer. It's going to have one less hydrogen. Butane, propane, 2-methyl propane. Could that be an isomer? Well, those are definitely isomers, but are they functional isomers? Or are they both part of the same family of alkanes? So those are isomers, meaning they have the same formula, but they have also the same functional group. We want something with different functional groups. Propan 1-ol, propan 2-ol are also isomers. Both of these guys are isomers. But they are called, both of these guys are isomers. But they are not functional isomers. They are what they have. You want something with two different functional groups. Those are structural isomers. Propanoic acid and methyl ethanoate. Now, the moment you see an oic acid and an ester, with experience, you'll know that probably is the right answer, because every year they ask that. An ester has got the same functional group as a carboxylic acid. But let's just check if that's correct. Propanoic acid has got 3 carbons. Methyl's got 1 carbon, and ethanoate has got 2 carbons. So there's your 3 carbons. So that D must be the correct answer. So that's an isomer, but those are what are called functional isomers, in that they've got 2 different functional groups. And those are not isomers, because if you count the atoms, they're different in those. So 3 are isomers, but this one's a functional isomer. Okay, a compound with a general formula CnH2n plus 2 is an the answer is in the plus 2. There's only one group that has got a plus 2. Is it alkanes, alkenes, alkynes, or alcohols? Who says it's an alkane? Okay, you guys are brilliant. We don't have to look further. Alkanes have got that formula. Alkenes are CnH2n no plus 2. Alkynes are CnH2n minus 2. Alcohols are CnH2nOH. Okay. Which one of the following is a functional isomer of butanoic acid? Come on, guys. We just said it. A goldfish would answer this question. I might not be able to answer it, but a goldfish could. Because less than 5 minutes ago, we mentioned oic acids and esters have the same, are normally functional isomers. So butanoic acid is 4 carbon. Let's have a look at this. 1, 2, 3, 4 carbon. Is that an ester? No, that is an acid. Is that an acid or an ester? 1, 2, 3, 4 carbon, and it's an ester. I don't have to look further. It must be B. Look at this one. 1, 2, 3, 4 carbons, but that is butanoic acid. So butanoic acid is not a functional isomer of itself. This one here is 1, 2, 3, 4 carbons, but it's got a double bond O. That must be a ketone. This one here is a carboxylic acid. It's 1, 2, 3. It is propan. It is 3. It is 2-methyl. 1, 2, 3. Propanoic acid. But it's not a functional isomer of that. That would be a structural isomer. Okay, so what is a functional isomer? It's got a different functional group. And the oic acids and the esters always are the ones they ask, which are functional isomers. What product will be formed when an alkene, no, we don't, we'll do a whole lesson on that, on substitution, addition, elimination. But let's just stick to naming for today. Consider the two inorganic organic molecules 1 and 2 below. 1, 2, 3 carbons, double bond O. 1, 2, 3 carbons, double bond O. Which one of the following represents the homologous series to which compound 1 and 2 belong? Whew. Okay, who says that something with a carbonyl group on the last carbon is a ketone? Hands up. Who says this is an aldehyde? Well done. Who says this is a ketone with a carbonyl group in the middle somewhere? Well done. So we got a ketone. I mean, we've got an aldehyde here. We got a ketone there. So just call me L. That's L. Just call me L. And there's your ketone. Okay, so now we go to the answers. That's an aldehyde. That's a ketone. So it must be B. Aldehyde, no, it's not an alcohol. It's not a ketone. So it's got to be aldehyde on the left. So the answer is B. So guys, imagine, these are all taken from past papers. If you had to get these same questions, and you will get the same questions. That's the beauty of physics. If you studied the last 3 years' papers, you've seen this year's paper. When you see the same question again, you're going to get 100%. And the reason is because you've gone through these past papers. That's why you're going to be such geniuses. A carbonyl group is the functional group of alcohols, ketones, haloalkanes, carboxylic acids. Okay, now I want to see hands. Who says the carbonyl group belongs to alcohols? Who says it belongs to ketones? Who says it belongs to haloalkanes? Who says it belongs to carboxylic acids? I was expecting a full house of hands here. Remember that carbonyl group is that C double bond O. Which one of these has got a C double bond O? Okay, let's start again. Alcohols, hands up. Ketones, hands up. Yeah. Okay, well done. Ketones it is. They're the ones that have, ketones and aldehydes have got a carbonyl group. Okay, consider the structure of an organic compound below. The UPAC name of this compound is. If you think you got an answer, won't you put a hand up? Okay, who thinks they've got the answer? Just put a hand up. Okay, I'll give you some more time. Okay, so let's go to rule number 1 of naming. What is rule number 1? Find the longest chain. Who says the longest chain is 3? Who says the longest chain is 2? Who says the longest chain is 4? Okay, there's the hint. The longest chain is 4. 1, 2, 3, 4. Don't be taken in by the rookie way they can bend the chain, so that you could start anywhere. 1, 2, 3, 4. But you can still get a length of 4. So if it's a 4 chain, it must be but something. Now, what kind of, is the but on the 2? 1, 2. I mean, is the ene on the 2? Okay, so who says the answer is 2,3-dimethyl butene? Who says that's the answer? Yay! Now, I wonder why all the answers are starting with an A. That's not very challenging. They should always put the answers on D. So we've got to go through it. Okay, look. It's got 1. On the 2 carbon is a methyl. On the 3 carbon is another methyl. And there's your end of the chain. So your chain goes 1, 2, 3, 4. And on number 2 and number 3 carbon, 2 and 3, 2, 3, dimethyl butene. Isn't that nice? I like that question. Any questions? Easy enough. Okay, 181. The boiling point of a compound is the minimum temperature at which it boils, the average temperature at which it boils, the maximum temperature it boils, when temperature equals vapor pressure. Who says the answer is A? Who says the answer is B? Who says it's C? Who says it's D? Wow. Yay. They took my advice. They put the answer at the end. But well done to you. You weren't fooled by the first one. Okay. The UPAC name of an organic compound with molecular formula C7H14O2. Won't you look at it for a while and just try and figure it out? And then also look at 192 and also 193. Okay, let's do 191. What is significant here is you find it's got 2 oxygens. Now, which is the only one here that's got 2 oxygens? Who says A? Who says B? That alcohols have got 2 oxygens. Look, there's only 1. What about heptane 2-ol? Isn't there 2 oxygens? Or what about this one, heptanoic acid? Yeah, well done. You weren't fooled by any nonsense. That's the only thing with 2 oxygens. Okay, what is an aldehyde? We're looking for a carbonyl group on the last carbon. Now, which of these has got a carbonyl group? That's got a carbonyl group, that's got a carbonyl group, that's got a carbonyl group, that's got a carbonyl group. But which of those is on the last hydrogen? Who says A? Okay, but that's an ethano, that is an, hello, hi, how's things? Thank you for sacrificing your computer.
Oh, no, that's an absolute pleasure, sir. Are they actually learning well? Are they quiet and listening?
Okay, well, fantastic, because I trod on so many toes. I'm not sure I'm going to be forgiven because I was interrupted teacher training and everything. It was very selfish of me, but my matrics are so important to me.
I agree with you. I think you're number 1 and they are number 1, sir. So well done. Thank you.
So when they get A's, maybe then everyone will forgive me.
You'll all get A's, that's what I said. Okay.
They're going to have to get their A's to make up for it, but I'm sure they will.
I think so too. Good. Thank you, Mr.
Okay, thank you. So which one of the following structures is the functional group of aldehydes? Okay, so we're looking for a carbon on the end. That C double bond O is a carboxylic acid. It's got 2 oxygens, it's not an aldehyde. Is that B the answer? Who says B? Well done. Because there, that carbon ends in hydrogen. You can see this chain is going nowhere slowly. It's going nowhere. It's ended. This CO could go anywhere from there on. It doesn't say, if it said H, but even so, this would be an acid. It's got 2 oxygens. And this is a ketone. Look, it's not on the N carbon. So well done. Okay, which one of the following reactions represents a cracking process? Okay, cracking theoretically comes with addition, elimination, but I think we can do this. 5 of those go to form, and that's a polymer. So that's 5 of those monomers go to form a polymer. That's polymerization. Because when you see brackets with a 5, it means it's added it into a long chain. So it's not A. Cracking is where a long molecule goes to form many smaller molecules. This is gaining hydrogen. That's hydrogenation. That's not cracking. This one is a long molecule, goes to form 2 smaller molecules. So that must be the answer. That's cracking. And this one is where it gives off water. That's dehydration. That's not cracking either. Okay, so the answer here must be C. A long molecule breaks up into smaller molecules. Okay, which one of the following is the general formula of alkynes? Ines. Okay. Who says it's A? Who says it's B? Who says it's C? Well done at the back there. Well done. It's C. So the general formula of alkynes is always -2. So there's your alkane +2. There's your alkene, CN, H2N. I don't know what this is. C2N, H2N is the same as CN, HN. That's nothing. I don't know what that is. So it's this one here. Which one of the following isomers has the lowest boiling point? So what is your algorithm? That means your method of solving it. Who thinks they know how you're going to solve this? Just your method, just a hands up. Okay, well done in the front there. I can see. Do you want to in the front there? Just, I'm sorry, I can't see who it is because my little screen of you. Would you just tell, it looks like it's Aiden maybe. Just tell them all how you're going to solve this. Okay, it's Ezra. Okay, I'm sorry, but my screen is tiny. Just tell them how you're going to solve this.
One of the least hydrogens is going to have the lowest boiling point.
Fantastic. So all you're going to do is go on hydrogen count. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3, 4, 5. Now remember that's doubled. Plus 6 is 11, 12, 13, 14. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, they've all got 14 hydrogens. So then what's the next thing that we're going to do? What are we going to do if they've all got the same number of hydrogens? We're going to then look for, Ezra, what are we going to look for then? Any ideas? Branches. Okay, you can see that's a straight chain. How many branches has that got? And normally you can see the branches are in brackets. So that's got like 2 branches, 1 branch, 1 branch. What do branches do? They push away each other. So think of branches as pushing away each other. So now because they've got the same number of hydrogens and carbons and everything else, they're all isomers. You look for which has got the most branches, and normally branches are written in brackets. So this has got 2 branches, 1 branch, 1 branch. So which one's going to have the lowest boiling point? Who says it's A? Who says it's B? Okay, well done, Ezra. Because the branches push it away, therefore they become less sticky. Branches mean less sticky and a lower boiling point. So you're looking for the more the branches, the easier it boils. That means the lower the boiling point. So the answer is B. That's got 1 branch, 1 branch. So 2 branches beats 1 branch. No branches, that would have the highest boiling point. An example of a saturated organic compound is, who says it's A, an ine? Who says it's ene? Who says it's ene? Who says it's ane? Who says it's ane? Well done. Saturated means it's saturated with hydrogens. You can't fit another hydrogen on, and that's the alkanes. All the ines and enes have got double bonds that can be broken and therefore can be saturated. 1.113. Study the structural formula of the functional group below. Okay, I've studied it. The structure above is the functional group of, okay, look, it's got a what are the carbonyl group in the middle? Is it an ester, a ketone, an aldehyde, or a carboxylic acid? Okay, let's start. Who says that's an ester? Who says that's a ketone? Well done. If it was an aldehyde, that O would be on the last carbon and we'd have an H. It would be C, double bond O, and there'd have to be an H there, and then that would be disappearing. That's got to move on to the end. Do you know what? I see we down to who remembers? Okay, let's do fertilizers as well. The preparation of nitric acid, is it known as the Haber, contact, or Oswald process? Who thinks they know the answer? Who says it's Haber? Who says it's contact? Who says it's Oswald? Yeah, Oswald process, the making of nitric acid. The Haber process is the making of ammonia. The contact process is the making of sulfuric acid. And the catalytic oxidation of ammonia. Okay, let's have a look at this 1, 2, 1. Which one of the following is the structural formula of the functional group of ketones? Is that a ketone? Is that a ketone? Is that a ketone? Is that a ketone? Do you know that I've actually got a question here? It's either, who says it's A? Maybe you can help me out. Who says that's a ketone? Who says that's a ketone? Who says that's a ketone? Okay, well done. Then the answer must be C. I'm just wondering why that's not a ketone. That's an alcohol. But if I just stop sharing for a moment and go back to this page here, just have a look at that. Do you see that under ketones, it gives that C double bond O, then it's got a carbon, carbon. So that is the correct answer. So from our book, we know that that is a ketone, that is an aldehyde. We don't do ethers, and there's our acids. So from going to page 80 of your textbook, you can see what the correct answer should be. Which one of the formula below represents an alkane? Okay, hands up, how many of you find this question a little bit boring already? I want you to be bored with them asking you the same question. I don't get bored because I like science, but okay. C2H4, that's CnH2n. C5H10 is CnH2n. C14H30 is CnH2n plus 2. C8H14 is CnH2n minus 2. So is the answer A? Who says A? B? C? Yeah, great, C. And D would be 2 8 is 16 minus 2, so that would be an alkyne. Consider the organic compound below. The UPAC name of this compound is, okay, let's just have a look at it. What is the longest chain? 1, 2, 3, 4. It's got 2 branches. And we always number it from the side that's got the most going on. So I wouldn't number this 1, 2, 3, 4, because this stuff is, there's a lot going on this side. So I'm going to number it 1, 2, 3, 4. So who says the answer is A? Who says the answer is B? Who says the answer is C? C? Who says the answer is D? Okay, those who said C, look, it's got dimethyl. There's one methyl. Both of them are on 2, so it must be 2,2-dimethyl butane. Don't be fooled by numbering it 1, 2, 3. So someone has said 3,3-dimethyl butane. We start with the end that's got the most, where the functional groups are closest to. Okay, 131. Which one of the following is a secondary alcohol? Now, I don't know if I've taught you this, so I'll teach it to you quickly. Who thinks they know what a secondary alcohol is? Okay, let me tell you the definition. A primary alcohol has the OH group attached to the last carbon. A secondary alcohol means that the carbon on which the OH is attached has got 2 other carbons attached to it. And if it's a tertiary alcohol, it means it's got 3 carbons attached. And if it's a, hang on, it's primary, secondary, tertiary, and then I forget, no, you can't have 4. Okay, that's, so we don't have to worry about that. So we're looking for an alcohol that is sitting in the middle of the group so that it's got a carbon and a carbon on either end. So you're looking for a C. Okay, be like that. So it's going to have an O and an H, but that OH group must be attached. This is a big of a program to draw on, by the way. You can see that. This carbon here must be attached to 1, 2 other carbons. Can't just be attached to one more carbon like this. So it must be attached to another carbon somewhere up there. So that means that this carbon must sit in the middle of a chain. So which of these is not at the end? Ethanol, is that OH group on the end? Yes. Butane 1-ol, yes, it's on the end. Butane 2-ol, it's in the middle. See, there's your carbon 1, there's carbon 2, there would be carbon 3. What about 2-methyl butane 1-ol? No, because it's again 1. So the answer has to be C, because a secondary alcohol must have a carbon and a carbon on either side of this carbon. Does that make sense, guys? Somewhat? Okay, I hope so. A functional isomer of ethyl propanoate. Do you know what? I'm not even looking at the rest of the questions. I know the answer. That's an ester. So I know immediately what I'm looking for. I'm looking for a carboxylic acid. Which of those is a carboxylic acid? Okay, who says it's A? No, that's a aldehyde. Who says B? No, that's an alcohol. Who says that's a carboxylic acid? Yes, okay, it must be C. Who says that? No, that's a ketone. I mean, that's an aldehyde as well. Look, the oxygens are on the end. So I'm looking for, if it's an ester, it's an oic acid. Please, they're going to ask you that. They ask it so often, which I love. You can never ask something often enough. It just makes me feel better when I know the answers. Makes me feel worse when I don't know the answers. Which one of the following compounds has the highest vapor pressure? Okay, so Ezra would tell you, what are you going to do? You're going to count the van der Waals, hydrogen, and hydrogen bonds. Van der Waal, dipole, and hydrogen bonds. And then you're going to say the one with the least is going to have the highest vapor pressure. So which of those is going to have the least? So you just go and work it out. Just count up what the stickiness factor of this one is. So how do you count the stickiness? That OH is going to be 10. That double bond O is going to be 14, plus that one hydrogen. This is going to have a stickiness of 15. That's 15. So that would be its stickiness factor. Okay, look at that. It's got a double bond O on the end. This is not an alcohol. That's an alcohol. That's a 10. This is just a 4, 5, 6, 7, 8. That's an 8. This one is a 10, 11, 12, 13, 14, 15. There's another 15. This one is a 3, 4, 5, 6, 7, 8. So this is a 4, 5, 6, 7, 8. So we're stuck between these two, which is going to have the lowest boiling point. Any ideas? Which of the, how many of you would choose B? How many of you would choose D? I would choose D, although both of them are 8s. When I see an O, I think they mean a dipole is stronger than just pure van der Waals forces. So although I say to the examiner, Mr. Examiner, having two that are both 8s is dumb. It's unnecessary. Why make both of these 8s? Make one, but then the examiners don't know everything. I don't think they use our method. Our method is our own method. So really what we're looking for from the examiner's point of view, this is only van der Waals forces. This is hydrogen bonds. That's dipole, and that's dipole and hydrogen bonds. So that's the way the examiner's thinking. Okay. Which one of the following formula represents the product of a polymerization reaction? That means where you make a long chain. So which of these formula looks like it could be a long repeating chain? Who says A? Who says B? Who says C? Who says D? Do you see this N here? What does that mean? It means this just keeps on repeating. This is a long chain of, this is a polymer called polyethane or polythene. It's just a repeating chain of C2H4. It's made from ethene. Lots of ethenes joined together. So the answer is C. That is a polymer. Whenever you see a little N here with a squarish kind of curly bracket, or whatever they call that kind of bracket around it, that means this is a long chain of something. You disappeared for a moment. Which one of the following combinations are both unsaturated hydrocarbons? Okay, just look at it and get an answer.
So what's the answer of the other one?
For 142. That is C. C, because it's got that N, which means this is a repeating unit. This is the monomer that makes up the polymer.
It actually will in the next 3 minutes. Okay, there we go.
I can hear you guys. Can you still hear me? Fantastic. Okay, which are both unsaturated hydrocarbons? Okay, is ethane unsaturated? No. Ethene is unsaturated. Okay, so is the answer A? No. Who says it's B? Who says it's C? Who says it's D? So what are we looking for? Ene and yne are both double and triple bonds. That makes it unsaturated. What is unsaturated? It's got more than one bond between the carbon. So the answer is B. Okay, guys. Now, what I want you to do is start working from the back here, the bottom, and work out the answers to electrolytic cells and cells in general. So do 149, 148, because this is what we did last time. Okay, so you need to, and do 150, we did fertilizers as well. So which of these catalysts is using in the Oswald? So just work your way back and do the fertilizer questions, which we never got to, and then the electrolytic cell questions. Thanks. And if you've got a problem, come and ask. But I think it's time you guys did those. So do from 150 backwards. Just the questions on fertilizers and cells. And then if you've got a question, you can just shout it out and ask.